My name is Musa Wala and I'm allowed to already on Islamic Temple. So as you all know, whenever I came with a new colony video, tell a story or interview. So today I came with a new colony video. So my topic of colony today is explore recent breakthrough in healthcare and medicine. So here we go. First we invite colony. Hi Maya.
Hi, Moise. How's your Saturday going so far?
It's good, it's good. Okay, so Maya, I'm going to ask you some question. Are you ready for that?
Yep, bring him on. I'm all ears.
Okay, okay. So Maya, my first question for you is, what are the biggest recent medicine breakthrough you have seen in 2024 and 2025?
Okay, good question. 2024 and 2025 that have been pretty wild for medical advancements, honestly. I'd say the biggest leaps are in personalized cancer vaccines. We definitely do.
Okay, so okay, so
A few that re a few that really stand out. Advances in GLP-1 receptor agonists.
okay, so Maya, my next question for you is, how has AI changed the landscape of medicine research in the last year?
Hold up, Sumaya. I thought my name was Maya. Just checking, haha. But okay, AI and medical research. Yeah, it's been a total game changer. It's not even a hype at this point. You all right? You went quiet there. Just wondering if you wanted me to keep going or if you needed a sec to process.
Okay,
No worries either way.
okay, so
Okay,
Maya,
so
okay, so
no
Maya,
problem at all.
okay, so Maya,
To
my
be able to,
next.
you cut out less wet. Sorry, the connection's a little choppy. Less stressful, less confusing. Just trying to follow.
Okay,
Still, cutting out a bit there. Are you maybe in a noisy area? No worries if so. Just trying to figure out how to make this easier for both of us.
okay, so Maya, my next question for you is that, are there any
Okay.
revolutionary new diagnostic tools that doctors are using now?
Okay. Gotcha. Revolutionary diagnostic tools, definitely. Liquid biopsies are a big one. They're getting way more accurate at detecting cancer early, just from a blood sample. It's way less invasive than traditional biopsies, you know?
Okay, okay. So my next question for you is that, okay, so Maya, my next
Yes?
question for you,
Lay it on me.
what is the most promising new treatment for cancer right now?
Okay, so a lot of buzz around CAR T cell therapy. It's not new, but the advancements are really impressive. Basically, they reprogram your own immune cells to hunt down and destroy cancer cells. It's showing amazing results, especially in certain blood cancers, though it's still pretty pricey and not a one size fits all solution, but definitely one to watch. All right, cool.
Okay. 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 ये वाली एक ये वाली नहीं है
You're welcome. What's next?
पीछे Okay, so Maya, my next question for you is that can you explain CRISPR latest application in healthcare?
CRISPR, yeah. Okay, so it's still early days, but CRISPR's applications in healthcare are expanding beyond just gene editing. A big one right now is diagnostics, faster, more accurate detection of diseases like COVID and other pathogens. They're even using it for more precise genetic screening. And there's research into using it to develop new antibiotics, which honestly we need badly. It's potentially huge, but there's still a lot to figure out ethically and practically.
Okay, so Maya, my next question for you is how close are we to fully personalized medicine?
Ooh, good one. We're getting closer, but fully personalized is still a ways off. We're seeing like bits and pieces of it now. Pharmacogenomics, where they test your genes to see how you'll react to certain drugs, is becoming more common. But to truly tailor everything, prevention, diagnosis, treatment based on your unique genetic makeup, lifestyle, environment, that's still pretty complex. Data privacy is a huge hurdle too. Probably another decade or two before it's really widespread, I'd guess.
Okay, okay, so Maya, my next question for you is what breakthrough you have been made in rare disease treatment? Please give me a long answer so I could understand easily.
Gotcha. Long answer on you're welcome. Okay, so rare disease treatment, a field that's historically been really underfunded and overlooked, but things are shifting, thankfully. A few breakthroughs stand out. Gene therapy is huge, obviously, especially for single gene disorders. We're seeing approvals for things like spinal muscular atrophy, a devastating disease in young children, and they're really life changing. Super expensive, which is a major issue, but the fact that it's even possible is incredible. Beyond that, there's a growing focus on repurposing existing drugs. Basically, taking drugs already approved for other conditions and seeing if they work for rare diseases. It's faster and cheaper than developing a completely new drug, though finding the right match can be tricky. And there's a lot of work going into improving diagnostics. A lot of rare disease patients spend years going from doctor to doctor without a diagnosis. Better diagnostic tools, thanks to advancements in genomics and AI, are speeding that up. Another big thing is patient advocacy. Rare disease communities are incredibly active and vocal, pushing for research funding and access to treatments. That pressure is making a difference. There's also more investment in developing platforms for drug discovery, specifically for rare diseases. It's still a tough road for a lot of patients, but the progress in the last few years has been pretty significant.
Okay, so my next question for you is that what role does wearable technology play in breakthrough?
Whoa, hold on a sec. Still Sumaya? My name is Maya. Just want to make sure we're on the same page. But yeah, wearable tech, that's a good one. It's becoming seriously important in breakthroughs, absolutely.
Okay, so Maya, my next question for you is that are there breakthroughs in telemedicine worth nothing?
Telemedicine? Could you clarify that? I'm not sure I'm tracking what you mean. Is that a typo? Maybe you meant nanotechnology or something else?
Okay, so the question is that are there breakthroughs in telemedicine worth nothing?
Okay, got it. You mean TLD as in three-letter drug. We're asking about breakthroughs in pharmacology and new drug development. Yeah, absolutely. A big one right now is the rise of GLP-1 receptor agonists, initially for diabetes, but now they're showing incredible promise for weight loss and even cardiovascular health. It's kind of a surprising turn of events. Also, there's a lot of excitement around antibody drug conjugates or ADCs for cancer treatment. They deliver chemotherapy directly to cancer cells, minimizing side effects. And of course, the mRNA vaccine technology, which was proven by the COVID vaccines, is now being explored for a whole range of other diseases, including cancer and influenza. It's a really exciting time in drug development. Do you want me to dive deeper into any of those? Still with me? Just checking in. Let me know if you want me to elaborate on anything or if you're ready for another question. No pressure. Okay, you're being very quiet. Is everything all right? Sometimes the connection is a bit spotty. Is it possible you're having trouble hearing me? If you just want to take a break, that's cool too. Just let me know. Okay. Well, I'll just wait for you to say something then. I'm here whenever you're ready.
Okay, so my next question for you is that uh, which breakthroughs are improving
Great.
which breakthroughs are improving healthcare access in low-income countries?
Whoa. Okay, that was a bit fragmented. Let's break that down. You're asking about what's improving health, specifically regarding vector-borne diseases like malaria, dengue fever, etc. You're welcome. Okay, obviously, insect value what? I think you cut out again. Value bed nets or something else? Just want to make sure I'm following.
Okay, so my next question for you is
Okay.
that what are the newest method of fight biotech resuscitation?
Okay, flight by recitation. That's a new one. I'm guessing you mean flight by simulation or maybe flight by verification. Could you clarify what you mean by recitation? Still waiting on a clarification. I'm happy to try and answer, but I need to understand what you're asking.
Okay, so Maya, my question is that how are robotics being used in surgery today?
Ah, okay. Now we're talking. Robotics and surgery, that's a really active field. The Da Vinci surgical system is probably the most well known, and it's used for a huge range of procedures prostatectomies, hysterectomies, cardiac surgery, and so on. It allows surgeons to make incredibly precise movements with tiny instruments through small incisions, meaning less pain and faster recovery times for patients. But it's not just about precision. It also gives surgeons a better 3D view of the operating field. Beyond Da Vinci, there's a lot of development in smaller, more specialized surgical robots and even robots that can assist with tasks like suturing. And there's increasing use of AI to guide robotic surgery and improve outcomes. Still there? Anything else you'd like to ask, or are you all
Yes,
set for now?
my question is that what role are AI diagnostic system waiting? Are AI diagnostic system all performing doctor in the same areas?
Okay, let's untangle that a bit. You're asking about the role of AI diagnostic systems and whether they're replacing doctors or working alongside them, right? And you're wondering where they're being used. Essentially, they're not replacing doctors, at least not yet, and likely not fully. They're currently best used as a tool to assist doctors, a sort of second opinion. They're really good at spotting patterns in images. Think radiology, dermatology, pathology, and flagging potential issues that a human might miss. They can also analyze large data sets of patient information to identify people at risk for certain diseases. Think early cancer detection, predicting heart attacks, that sort of thing. As for where they're being used, radiology is a huge one, as I mentioned. Also, ophthalmology, AI can detect diabetic retinopathy and other eye diseases with high accuracy, and increasingly in primary care to help with initial assessments and triage patients. It's all about augmenting a doctor's abilities, not replacing them, at least for the foreseeable future. They really shine at high volume repetitive tasks, freeing up doctors to focus on more complex cases. Does that make sense? Why am I
Yes,
trailed off
yes.
again? Did you want me to?
And my next question for you is what are the newest method of fight biotic agitation?
Okay, so you're
Please give
the
me,
newest of
please give me a long answer
biorobotics.
so please give me a long answer so I could understand easily.
Okay, you got it. A long answer on biorobotic adaptation. It's a really fascinating field, and it's evolving incredibly fast. Essentially, it's about integrating living organisms or biological materials with robotic systems to create something new with enhanced capabilities. Here are a few major approaches. One is using living muscle tissue to power robots. Scientists have grown muscle cells and used them to actuate small robots, mimicking natural movement. It's early stages, but the potential for creating soft, adaptable robots is huge. Another area is biohybrid robots, where you combine biological. That's awesome to hear. It's a pretty cool field, right? Anything specifically about biorobotics you'd like to explore further? Or should we move on to something else?
My next question for you is that can damaged organs ready to repair with negative medicine?
Okay, negative medicine. I assume you mean regenerative medicine? Sometimes the audio cuts out, but yes, regenerative medicine is making huge strides in repairing damaged organs. It's no longer science fiction. There are a couple of different approaches. One is using stem cells, basically cells that can turn into any other type of cell, to regrow damaged tissue. We're seeing success with this in things like skin grafts for burns, and there's huge potential for using it to repair heart muscle after a heart attack, or even grow entire organs for transplant. Another approach is tissue engineering, essentially building organs from scratch in a lab using a scaffold material and seeding it with cells. It's incredibly complex, but there's been some real progress with things like bladders and tracheas. And then there's gene therapy, where you use genes to stimulate the body to repair itself. It's all still relatively new, and there are a lot of challenges, but the potential to repair and even replace damaged organs is getting closer and closer to reality. Are you thinking about a specific organ or type of damage? That might help me give a more focused answer. Still there?
Okay,
Just
so
let me know
Maya,
if you
my
want me to
next question
continue.
for you is that how are there smart drugs being tested now?
Okay, first, it's Maya. Just a friendly reminder. And second, smart drugs is a bit of a broad term, so I'm assuming you mean drugs that target specific pathways or cells in the body. How they're being tested is evolving. Traditionally, it was huge clinical trials, but now we're seeing more use of things like biomarkers, measurable indicators of a disease or treatment effect, to track how a drug is working in individual patients. Also, a lot of computer modeling and AI is being used to predict how a drug will behave and identify potential side effects before it even gets to human trials. And personalized clinical trials, tailoring the drug dosage and treatment plan to the individual's genetic makeup and other factors are becoming more common. It's becoming less one size fits all and more about targeted, individualized therapies. They also use organ on a chip technology, which essentially mimics the function of human organs to test drug effects. Does that
Okay,
help clarify how things are evolving?
So Maya, can you give me any last advice from audience and any big advice who are watching you?
Evolving?
No, no, please give me advice from audience who are watching you.
Okay. For everyone watching, my advice would be this: stay curious. Seriously. The world is changing so incredibly fast, and the more you learn, the better equipped you'll be to navigate it. Don't be afraid to ask questions, even the ones that seem silly. Embrace lifelong learning, not just to advance your career or acquire skills, but to broaden your perspective and become a more informed citizen. And importantly, use your knowledge to make a positive impact, whether it's volunteering your time, advocating for a cause you believe in, or simply being a kind and thoughtful person. Find ways to contribute to making the world a better place. It's easy to feel overwhelmed by all the challenges we face, but remember that even small actions can.
Okay, so this is our today my session. I hope you like it. We made it